Hi everyone and welcome to our first Cape Bionics podcast. My name's Dr Annette Eastwood and I'm a sports physiologist and I've been on board with Cape for some time now. Prior to working with Cape, I was involved in elite sport in Australia for about 15 years and worked with a number of high performance athletes and coaches who were competing at Olympics and World Championships. As coaches and physiologists, we're fascinated by ways to improve performance and recovery. So when I heard about Cape, I was really excited about what they're doing in the area of compression. So today I'll be talking to Dr. James Waldie, who is the founder and CEO of Cape Bionics and an aerospace and bioengineer. Hi, James, and welcome.
Hi, Annette. How are you?
I'm good, thank you. Can you tell us a little bit about your background and the work that you've done in the area of compression and how Cape Bionics was started?
Yeah, sure. I've been working with compression garments for about 2 decades. I've done a lot of academic work, a lot of postgraduate work, 2.5 years at MIT as a postdoc, consultancy at NASA, and co-principal investigator work with the European Space Agency. And it was through ESA that one of my suit designs actually got onto the space station in 2015 and also again in 2017 for a long duration deployment. And it was working with aerospace and also with the medical industries that I learned about compression, its physiological benefits, and how to make compression work. And one of the key things I saw was that effective compression was being offered in these industries, but not in the sports industry. And that's where I thought some of the primary benefits could be realized. So that's why we started Cape. We brought in all the experience from those other industries. We brought in all the physiological learnings, and then we brought in further sports-specific physiological data and results from the literature to combine together to form a really unique offering into the sports industry, and one that supplies the industry with something that I think they deserve.
Great. Can you tell us a little bit about what it was like working at NASA and some of the research that you did in the area of compression with astronauts?
Yeah, we did a few things with NASA. One of the first things I did in San Diego at the University of California was working on a new form of compression gloves. And this was all about revolutionizing spacesuits that you all picture when you think of spacesuits, those big white, big body-shaped balloons that astronauts wear when they go outside. They're called extravehicular activity or EVA suits. The problem with those suits is that they're big, bulky, stiff, rigid balloons that make it very difficult for the astronauts to move in. They've been a triumph of engineering in allowing people to go outside and walk on the moon and build and maintain the space station. But it's that mobility that still presents a challenge, and still to this day, particularly with the Moon to Mars initiatives that are going on now. So for a long time, there has been research into using compression to form the basis of a spacesuit that's used outside. And that is that instead of applying pressure to the body via the air in this balloon that's the suit, it provides compression and physical compression. And then you have a helmet which is pressurized with the breathing oxygen as per normal. So I was involved in development and testing of a glove, which is perhaps one of the most fundamental parts of the whole EVA suit, because that's the primary interface that an astronaut has with the environment. It's also perhaps the most defining challenge in suit design because of the intricate and complex jointed geometry of the hand, and also because it's quite easy to test, because you can use a low pressure or hypobaric chamber quite easily with just the arm and the glove unit. So you don't have to have the whole body in a low pressure environment to suit the glove. So that was some of my early work. I was also working at Houston, at Johnson, to explore some of the injuries that astronauts suffer when they're using the current gas pressurized gloves. And some of the astronauts suffer from a thing called onycholysis, which is the degradation of the nail bed. And some astronauts have actually lost nails through the training or space flight during EVA. So obviously this is a very painful and significant physiological injury to overcome. So we were measuring some of the pressure points and some of the pressure that the current glove applies to the hand, which was really interesting because it changes according to the articulation of the fingers. So normally the glove is tuned to a certain hand pose, but of course, as you grip and extend, it changes the length of the glove, and therefore the glove fingers start to change, and that's sort of thimbles at the end of the fingers can start to impact on the fingertips and on the nails. So it's a really significant issue, and it's something that's so bad that one astronaut actually had his fingernails removed before the mission. So we did a lot of work on that as well, and also it's a NASA sponsored work with MIT when we were working on the biosuit with Professor David Newman, and working on concepts and new designs on trying to realize these full compression EVA suits and trying to progress them to be feasible. And the major challenge of that is trying to activate the elastics because the suits are really quite tight. They're around a third of an atmosphere, and that is something that you've probably felt having your blood pressure taken before. You'll know when the doctor pumps up the cuff at its very tightest, that's about the sort of pressure that we need to apply over the whole body, about 220 millimeters of mercury. And you've probably realized, Annette, that that's quite painful, and you certainly notice it when it's pumped right up. Yeah. And that's painful because it's just at a very local point on the body. If that pressure is applied evenly all over the body, or maybe just on the limbs, and you have a gas pressurized torso and helmet, however the suit is designed, then that's actually quite comfortable. And applying an extra third of pressure on the body is something that we do quite often. If you dive underwater down to a depth of 3 meters, for instance, then you're applying that same extra pressure on the body, and that's quite comfortable. So that's the sort of pressure that we're trying to apply with elastics. And to do that, it's almost certain that we'll need to go to some sort of activated elastic that relaxes, and you can get into the suit, and then it compresses and gets tighter as the airlock pressure drops. Then your suit gets tighter around you, and then suddenly we have a suit design which is far more mobile, much lighter, much less bulky, and would not cause a catastrophic decompression in the suit system if you scratch just one part of it, which the gas pressurized suits would do. So that's perhaps a meandering response to your question there, Annette.
Yeah, that's awesome. I think as physiologists and coaches, we've used compression widely with athletes, but nobody ever really thinks about how it's used in other areas, and space being a classic example there. So yeah, really interesting stuff. Okay, so you've talked about the benefits of compression for astronauts. Can you explain how compression can benefit elite athletes?
Sure. There are a whole number of areas where compression can impact all athletes, really, but particularly professional and elite athletes. The first and the most important one, and the area that we have the most interest in, is recovery. And that is after athletic load, after the game, after training. And the heart rate is down, blood flow is back down to normal. And what we want to do is still deliver blood flow in high volume and provide those nutrients and evacuate the waste products that otherwise wouldn't happen to the same degree as if you were wearing the appropriate compression garments. To make that optimal, there are specific compression regimes just for that purpose. There are other areas also that compression is critical. Another travel is another one that's in high demand, and that's to try and reduce the chances of DVT. With athletes traveling a huge amount these days, we've seen a lot of demand for travel garments as well. There's also compression regimes which are specific to performance and training. And these are regimes that are designed to augment blood flow and muscle oxygenation and so forth when a person is actually moving. So they have high heart rate, high blood flow. And so we have a different compression regime, which is optimal for that condition. And then we also have very high compression regimes, which adhere to the European Clinical Class 2 levels, which are really in play with garments such as knee sleeves for post-surgery applications and things like that.
Right. So why is it important for athletes to have customized compression and compression that really fits them specifically?
Yeah, it's critical that for compression to work, it has to be custom fit. That's what the aerospace and the medical industries already knew actually before I got in there. We found that out, and when we spoke to others, they said, of course, it has to be custom fit. So when you look at the sports industry, it's essentially being supplied with more affordable garments, but that are off the shelf. And the problem is that within each of those off the shelf sizes, there's a whole range of athlete size that fits in. And there have been a number of studies that have looked at the variance in athlete and calf or leg size that would be applicable to each of those off-the-shelf sizes. And because of that, the garment is stretched a different amount on different people, and therefore the pressure and compression that's exerted is different for different people. So what that means is that the compression on athletes is hugely variable because you have different size athletes within each standard size. You have different companies that are trying to apply different compression levels on their athletes. And so you have this huge variance of compression on athletes, and therefore you would have a huge variance in the output and the benefit. And that's exactly what we see in the literature. There's a lot of people that read all of these reports and studies of compression that says it's fitted according to manufacturers' recommendations. And as soon as you hear those words, you know that it's just an off-the-shelf garment. It means the compression is unknown, and it means the output cannot be relied upon. It's no wonder that there's a healthy question about whether compression works in the sports industry. And this attitude was something that we really wanted to appeal to in Cape and say, hey, the sports industry has been left behind with effective compression design. And that's why Cape exists, to fill that gap and to provide custom fit and therefore effective compression that's genuinely and consistently delivering benefit to athletes, not just using them for advertising, but actually bringing real benefit to them.
That's excellent. Yeah, certainly a lot of the latest research in this area is suggesting that for compression to be effective and to get those physiological benefits, then it's essential that it's custom fitted. So it's fantastic that Cape are going ahead.
Absolutely, yeah.
Can you explain a little bit about how the garments are custom fitted to the athlete, what process that you go through in ensuring that?
Yeah, sure. I mentioned before that the current sports garments are made to a certain price point, and they are more affordable, and they probably need to be than the aerospace and medical garments. So what we've decided to do is to develop some technologies that automate that custom fitting so that we can make them faster and with less manual work, so that they become more affordable. And what we've ended up developing is a system called Auto Tailor. And what that does is it enables us to take a 3D scan of an athlete, the material properties of the garment, and the compression regime that we need. And then it analyzes all of those inputs and custom designs the garment straight for that person and straight for that application.
Wow.
So instead of using tailor's tape and having to have someone there take a few measurements at key landmark points on the body, what we do is we take a 3D scan, which is much faster, and then we have that system which can take hundreds of measurements of that athlete. So we can custom fit to a hugely improved level of accuracy, while also improving the speed in the design of those garments itself. So we're very proud of this system. It's under a worldwide patent application now, as you can imagine. And what we've seen in developing this automated and more accurate system for sports is that now the aerospace and the medical industries are now looking at us and asking us if we can apply this technology back to them. So not only are we proud that we've sort of offering the sports industry something that's at world standard, but I think we've pushed it a bit more and getting the attention from other industries.
Yeah, definitely. That's fantastic. Okay, so can you tell us about the future of Cape and where you see it going from here?
Yeah, absolutely. So we're expanding quickly into the US. We've seen some great demand over there from professional teams. So we're increasing our number of Cape reps in the US. We're also going to commence manufacturing in the US very soon to be able to provide very quick turnaround for our customers there, and also look to Europe as well. Expanding on obviously our first market, which was Australia. So we're also looking at the release of our leggings very soon. Again, they'll be available in all those different compression regimes: recovery, travel, performance, and rehab. And they join our calf sleeves, knee sleeves, leg sleeves, and arm sleeves. The other thing that's really exciting for us is that we get to visit all these amazing teams and athletes, and we talk to them and then we scan them. But a lot of people don't have the ability for us to quickly go to them and to scan them, or we don't have the ability to get to them in a timely manner. So what we're also developing is a phone scanning capability where people will be able to use their own phone to scan themselves, and that will be the input into our Auto Tailor system and will allow us to custom make to very high accuracy and to a compression regime that's applicable to them at a really affordable price, and also be able to turn that around very quickly and deliver it out to them. The other thing that's really exciting is that we're back working in the aerospace industry again. So we're developing and improving 3 different types of compression spacesuits in a collaborative program with the Australian Space Agency, with NASA, with ESA, and with MIT and with others. We're looking at refining the space walking suits, the EVA suits. We're looking at refining gravity loading suits that are worn inside the spacecraft, and they have a very custom compression regime to try and impart normal gravity-induced loading on the musculoskeletal system that we have to be strong to support here when we stand on Earth. But then that disappears up in space, and the body adapts and atrophies quite significantly, up to 2% bone mass per month. So that gravity loading suit is worn inside the spacecraft, and we're working on that. And that was the suit that I designed almost 15 years ago now. So very pleased to be able to continue that work. And then we're also looking at refining orthostatic intolerant intolerance garments. And that's when astronauts return back to Earth and they're used to having an equalization of blood pressure all over their body. And when they return to Earth, blood is again pulled to their lower extremities under the action of gravity, and they're not used to that lowering of blood pressure into the brain, and they're subject to fainting. So we have what's very similar to G suits for astronauts that they can wear before, during, and after return to Earth. So we're really excited about all sorts of things happening into the future.
That's really exciting, not just for athletes, but for astronauts as well. So exciting times ahead. Okay, well, thank you very much for your time today, James.
Oh, that's no problem. Hey, I want to throw it back to you, Annette, because I think there's been a lot of talk about me, but I'm obviously really interested to hear about your experiences, because we got you into Cape because you've got some fantastic experience at the Olympic level and with compression with athletes that are at the Olympic Games. So could I throw it back to you and ask you about your experience with it?
Yeah, sure. Used compression garments widely with athletes for a number of years, particularly in high performance programs where athletes are traveling a lot. So I'll just give an example of the year that we went to the Rio Olympics. It was a really hectic competition schedule for the athletes. So we were over in Europe prior to the games, spent a few months over there. And we were also in Asia and Japan for a race there, went over to Rio Games, came back to Australia, and then went over to Mexico. So their travel schedule was really intense. So definitely using compression garments for travel. That was just with triathlon, but a lot of the high performance programs are exactly the same. They have very busy travel schedules. So the travel garments were always used by elite athletes. Right. But also during competition as well. So quite a few of the sports I worked with, like cycling and rowing, they'd often have multiple events in one day. So recovery from one event and preparation for another is critical. So again, that's where compression garments can be really useful, sort of between events on the same day, but also backing up day after day. And the athletes certainly would report feeling a lot better and feeling less feelings of muscle soreness and improved perceptual recovery if they were wearing compression garments between events and between days.
Right. And the custom fit element of that separates sort of fashion compression with effective compression, that makes sense to you as well? Yeah,
definitely makes sense for elite athletes because they come in all shapes and sizes. So one size does definitely not fit all. It doesn't fit anyone really. So yes, definitely a lot of the research now is suggesting that garments should be custom fit. There is some research that has shown very little benefits of compression, but like you said earlier, it's more likely to be a result of the fit and just following manufacturer's advice rather than actually specifically tailoring them to the athlete's measurements. So
yeah, and the application too, to have the right compression regime and the custom fit.
So having the right compression regime and the custom fit will mean that Cape will be leading the way on any other brands out there because, like you say, most of them are just a fashion brand and not really catering for the needs of elite athletes.
Well, that's what we're here for. That's why we started it.
All right. Thanks, James. Great talking to you today. And if anyone wants any more information about what we do here at Cape and our garments, please visit the website, capebionics.com.